Problem 5 of Chapter 18 asks us to find the equivalent resistance between points A and B and calculate the current in each resistor of the potential difference of 34 volts applied between these 2 points. So let's get into it. First, I drew this out so I can understand it better. But also, I drew the 34 volts here, but we're not going to use it in part A. In part A, it's kind of simple. You just, first, for part A, I suggest you tackle the parallel circuit. So you just add the resistance up in a parallel circuit, and you get 70 over 17. I'm using fractions, but I'll get to this later. Then you add up all the resistors. You add up the 4 ohms, the 9 ohms, and the 70 over 17 ohms tongue twister, and you get 291 over 17 ohms. Here's where I'm just gonna go point this out to you. In the back of the book, it says 17.1 ohms, but that's basically the same. Here, I'll prove it. See, basically the same. I prefer the fraction form because I like it being more accurate. Part B equations here are also in fraction in decimals, so don't worry about that. Because fractions or decimals, either one can work, but I prefer to use fractions in this case, so I'm going to use the fractions. Okay, speaking of part B, we're gonna have to tackle part B. Ignore that. That was my homework for problem 6. Okay, in part B, you're gonna have to use volts equals current times resistance, which is 34 volts equals 291 over 17 ohms times current, and you get current equals 578 over 291 amps. Again, you can back to the calculator, and it's all 1.99 amps. Because current's the same throughout the circuit, you have the current for resistance, the 4 ohms and 9 ohms, as you can see here. But because here's the but with parallel circuits, it's kind of tricky. The current wants to go through the 7 ohms because it's it's weaker than the 10 ohms because like us humans, current is lazy, so it wants to take the easiest route possible. But some will split and take the 10 ohms. But how do we solve this? Okay, so I'm gonna tell you. So this is how we're gonna do it. So try to keep up. First, because we know that current will always travel through the lower value ohms. That means that the low value is going to have more than 10. So how do you solve this? Here's how I solved this. You're going to have to add up both resistant values of 7 ohms and 10 ohms to get 17 ohms. But since more current will go to 7, you're going to have to put the higher resistance 10 on top of it to get the fraction. Shouldn't I have? So multiply our 578 over 291 amps by this decimal fraction, and you get 340 over 291 amps. Now subtract that amount from our original 578 over 291 amps, and you get 238 amps over 291 amps. Okay, I hope this is helpful for you. Good luck on the next test, and don't worry if you use fractions or decimals. They all work in the same. Bye-bye.